Hi friends, welcome back to Edupedia World. In our previous two lectures, we discussed about work and power and energy. In both the lectures, we saw one very simple example to basically understand the concepts, but we did not dive into the detailed numericals. So that is what today's lecture is targeted towards. I will not go into any theory today. I will work on different numericals concerning work, energy, and power today. This numerical says that a man pushes a box of 10 kg, the mass is 10 kg, up an incline of 10 meter. As shown in the picture, this is the 10-meter incline. This length is 10 meter. And a horizontal force of 100 Newton is applied on the box. 100 Newton horizontal force. The speed of the box is constant throughout, which means that the speed here is the same as the speed of the box here. There is no change in the speed of the box. The question asks us to find work done by the force, how much work this force does. Second, work done by the gravity. Now, since the box is going up the incline, it is increasing in height and gravity acts downward, there will be a work done by the force of gravity. The question asks us to find that. And apparently there will be a difference in these two values. The third part asks us to justify the difference. So let us first start with the first part. And the first part says what is the work done by the force. To find the work done by the force, we first need to write down the force. The force in the horizontal direction, I am writing that as FH, is given as 100 newtons. And the displacement in this direction is 10 meters. Let me represent it by S is equal to 10 meter. We know that the work done by a force is calculated as the dot product of the force and displacement. So to find the dot product, we know that the theta here, the angle between the force and the displacement is 30 degree. So we can use the theta as 30 degree. And then the work done would be F times S times cos theta, which comes out to be 100 times 10 times cos 30. Cos 30 is root 3 by 2. If we substitute it, we'll get the equivalence as 500 root under 3 joule. Therefore, the work done by the force on the body is 500 root 3 joule. This is one way of doing the first part. The second way would have been taking the component of force in the direction of the displacement. Or the third method would have been taking the component of displacement in the direction of the force. Let us try to do by the third part. To do by the third method, to do that, we first need to find components of the displacement. So this is the horizontal and this is the vertical. Now if this is 10, if the hypotenuse is 10, then this distance, the horizontal distance, will be 10 cos 30. That would come out to be 10 times root 3 by 2 or 5 root 3. Now if we use this value and the 500 Newton, then alternatively we can say that work done is equal to force into displacement in the direction of force. I am writing this as D, or let us write this as S horizontal and this as F horizontal. So that would give us, now since both are in same direction, we can simply multiply them and that will give us the same result. So we see that we can use different approaches to solve the same problem. I'll leave it as an exercise for you to try and solve this part by taking the component of force in the direction of the displacement. That will ultimately give you the same result, so I'm not doing it. Try it out on your own time. Let us now see how to do the second part. The second part says that what is the work done by gravity. Now we know that the gravitational force always acts downward, and we have 10 kilogram. We know that the gravity is 10 meter per second square, so the force of gravity will be m times g, and that turns out to be 100 Newton acting downward. Now we have a displacement of 10 meter along this direction, so we gain a height of 10 sine 30. This is 30, this is 30 degree, this is 10 meters, so this height gain is 10 sine 30, which is equal to 5 meter. Now the force of gravity acts downward. The displacement is in the upward direction. Then what will be the work? The work will be the force of gravity mg times the displacement in the vertical direction. I'm writing it as SV times, since they are anti-parallel, this is downward, that is upward, it will be a negative, or we can alternatively not put negative here but write a cos 180, that will bring the negative automatically. This will give us minus 100 times 5, that is minus 500 joule. So the work done by gravity is minus 500 joule. What does this mean? This means that the direction of displacement upward is opposite to the direction of force, resulting in negative work done by gravity. For this part 2, for the second part 2, we might have done in the alternative ways suggested in the first part. I suggest you try those on your own. They should give you the same end value. Now the third part says that the reason for the difference. What is the reason for the difference? Difference between what? Difference between this work done and this work done. Since there is no increase in speed, there is the same speed here and here, there should have been no difference in the value of work done by the force and the work done against gravity. But there is a difference. What is the reason for that? The reason is there is friction, and that friction is consuming some energy. So we are actually supplying 500 root 3 joules energy. We are getting out, or we are consuming 500 joules to overcome the gravity. Therefore the rest energy, that is 500 root 3 minus 500, this much joule of energy goes to overcome frictional forces. Frictional forces. We will read in later chapters that work can neither be created nor destroyed. So there should not be any disparity in the amount of work. Amount of work done should be equal to the amount of work consumed. Therefore, obviously this disparity has to be accounted for, and that disparity is consumed by friction. Let us now do another question and see further details into power and energy. This numerical says that a boy of mass 40 kg, mass of the boy is 40 kg, and he is climbing 50 stairs in 30 seconds. So he is going up, he's climbing the stairs, and each stair has a height of 25 centimeter. Now we have to find the work done by the boy and the power spent in watt and horsepower. First, the mass is 40 kg, so the weight of the boy, weight W is equal to m times g. G is given as 10 meter per second square. If it is not given, we would take 9.8 meter per second square, but since it is given, I will use that value, and that will be 10 times 40 times 10, which is 400 Newton. So the weight of the boy is 400 Newton, and the weight will obviously act downward. Now he climbs 50 stairs, and each stair has a height of 25 centimeter. So total height climbed is equal to 50 stairs into 25 centimeter each stair. Now we are dealing with SI unit here, but the centimeter is in CGS system, so we better convert it into SI unit. 25 centimeter is 25 divided by 100 meter, and that gives us the total height of 12.5 meter. So the boy climbs 12.5 meter, and his weight is 400 Newton. So the boy has to basically work against the force of gravity. And how much work does he have to do? Work needed to be done is the force of gravity, that is mg, into the total height h. Since we are finding out the work needed to be done, we will take it as positive. If the question asked us to find the work done by gravity on the boy, we had to put a negative. But since we need to find how much work the boy does, it will be a positive quantity. Now mg, as we know, is 400, and height is 12.5 meter, and that would give us 400 into 12.5, 5,000 joule. This is the amount of work done by the boy. The first part, we have got it. Now to solve the second part, we are supposed to find the power spent, and we know that power is work by time. We just found out that the work done by the boy is 5,000 joule divided by, we have 30 seconds mentioned in the question as the total amount of time required. So 5000 divided by 30, that would give us 500 by 3, which is approximately 166.67 watt. Now this is the power spent by the boy. We have got the power spent by the boy in watt, but the question also demands us to find the power spent in terms of horsepower. Now we know from our discussion that 1 horsepower is approximately 746 watt. Therefore, the power in horsepowers, power in terms of HP, will be 166.67 divided by 746. 166.67 divided by 746, that is approximately 0.223 horsepower. So the boy's power spent in terms of horsepower is 0.223. In this question we found out work, we found out the power. Now let us do a final example. The last numerical that we are going to discuss today says that electric heater of rating 1.5 kilowatt. So the power rating of the electric heater is 1.5 kilowatt, is used 2 hours every day for a month, and the month is said to be assumed as 30 days long. So 2 hours every day for 30 days. We are supposed to find the energy consumed in kilowatt hour and in joules. So the total time the heater runs during the month is 2 hours per day into 30 days of the month, that is 60 hours. And the power rating, as we know, is 1.5 kilowatt hour. Therefore, the energy consumed in kilowatt hour, would be the power in kilowatt multiplied with the time in hour. We have them readily available here. The power is 1.5 kilowatt and the time is 60 hours. That would give us 90 kilowatt hour. So the energy consumed over the month by the heater is 90 kilowatt hour. The second part, we are supposed to find the energy in joule. We will directly use this value of energy and convert this unit to joules. Now energy is 90 kilowatt hour. We need to convert it into the SI unit joule. So first we write it down as 90 into 10 to the power 3 kilo to watt hour, and then watt is now in the SI unit, but hour is not the SI unit. We need to convert the hour into second. So how can we do that? 90 into 10 to the power 3 watt times 1 hour is 60 minutes and 1 minute is 60 seconds. So this is in seconds. Now we have watt second, and we know that watt times second is basically joule. So we have the values 90 into 60 into 60 into 10 to the power 3 joule. Now there are 1, 2, 3 and 3, that is 10 to the power 6, and 9 times 36 is 324 into 10 to the power 6 joule. So this is the equivalent energy spent in terms of joule over the month by the electric heater. I hope with the examples discussed today, you might find it much more easier to understand the whole concept of power, energy, and work. With this, I will conclude today's lecture. In the next lecture, we will see the different forms of energy. Till the next lecture, have a great day. Goodbye.